Hi, my name is Matt Roscoe. I'm at the University of Montana, and I'm going to share a short video with you about how to use a Venn diagram to find the greatest common factor and the least common multiple of two whole numbers. So let's get started. Okay, as I said, the strategy we'll be taking a look at is the Venn diagram strategy. In the Venn diagram strategy, well, we need a sample problem first, so we're going to try to find the least common multiple of 16 and 24 and the greatest common factor of 16 and 24 as well. So the first thing we have to do in the Venn diagram strategy is to find the unique prime factorization of both 16 and 24. So to find the unique prime factorization of 16, I'll use a factor tree. It's 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. Each one of these branches I terminate when I reach a prime number. So we can see that 16's prime factorization, or unique prime factorization, is 2 to the 4th. We can do the same thing then for 24. Let's work in a different color. For 24, we'll work in blue. So 24 can be written as, let's see, 2 times 12. 12 is 3 times 4, and 4 is 2 times 2. So if we look at its prime factorization, or unique prime factorization, it is, see, 24 can be written as 2 to the 3rd times 3. Okay, well, let's go ahead and construct a Venn diagram then of these two numbers' prime factorizations. Go ahead and draw in a Venn diagram square, I guess, in which we'll put the factors of these two numbers. So I'll use a black circle to represent the number 16, and I'll use a blue circle to represent the number 24. And what I'll do is go ahead and distribute the factors of each according to whether or not they belong only to that number or to both numbers. So for example, in 16's cases, well, when I look at the two numbers, let's go ahead and underline here. When I look at the two numbers, I can see that they share, let's see, 1, 2, 3 factors of 2. So that means a 2, and a 2 should go in the middle. And since those 3 2's have been taken care of, the 2 to the 3rd here, I'll put an extra factor of 2 there. And since these 3 2's have been shared here, I'll put an extra factor of 2 over here. And once again, the black number, of course, is 16, and the blue number is 24. So now, how do we find, first of all, the greatest common factor of the two? I'll give you a second to think about it. Where on the Venn diagram do you think the greatest common factor for the two numbers are? If you're sitting with a partner, you might verbalize this now. I'll give you 15 seconds to think about that. Okay, if you said that the greatest common factor were the factors that they shared, in other words, the factors that are in the the intersection of the two sets of prime factors, then you are correct. The greatest common factor of 16 and 24 is 2 times 2 times 2, or 8. It's this region in the middle. I'll go ahead and outline it in red. This is the greatest common factor region. Okay, so now think to yourself, where would the least common multiple of 16 and 24 be? I'll go ahead and give you 15 seconds to think about that as well. Okay, well, the least common multiple is a little bit more tricky to think about. Remember that for it to be a multiple, it's got to contain 16, or all of the factors of 16. So it's got to be some multiple of all the black numbers. But it also has to be a multiple of 24 because it's a multiple of both. It's a common multiple, so it has to contain all of the factors that are the blue letters, or the blue and red, black letters in the middle. So that means it has to contain everything in the blue circle, and it has to contain everything in the black circle, but it has to contain them in a least sense. So in other words, not throwing in any extra. So in a least sense, a set of numbers that contain everything that's in the black circle and in the blue circle is this set of numbers that I'm dotting. So it's the whole group, what's in both the blue circle and the black circle, including their intersection. So that means that this number would be the 2 over here, the 3 2's in the middle, and the 3 on this side. And I'll go ahead and highlight this, and we'll go ahead and calculate it first. So 2 times 2 is 4, 4 times 4 is 16, and 16 times 3 is 48. So it turns out that this number is 48. One thing that should be interesting, or at least arise when you come to look at this, is that you can see right away that the least common multiple will always be a multiple of the greatest common factor, because the greatest common factor is contained in the middle here. The least common multiple contains the greatest common factor, and you can actually see that here in the diagram, because these blue 2's and these blue 2's are contained in both of these two numbers, in the 8 and the 48. So that's kind of an interesting fact from number theory, that the least common multiple is always a multiple of the greatest common factor, or contains the greatest common factor. Anyway, I look forward to you mastering this on your own and then teaching it to another participant in our summer academy.